Hello, today we're going to talk to you about ratios and proportions. This is Chapter 2, Lesson 6 in your book, and it's found on pages 111 through 117. Let's get started. So the first objective today is to compare ratios, and before we do that, I want to get into a few key vocabulary terms for this chapter, this section. And the first is the ratio. A ratio is a comparison of two numbers by division. You can see them written as x to y, x colon y, which is just read as x to y, and x divided by y. All right, and when we set two ratios equal to each other, that is called a proportion. You have done problems like this last year. You use cross multiplication to solve them. We're going to do the same thing this year. We're probably going to make them slightly more difficult this year, but let's get started. So, the first thing we want to do is simply to compare ratios. So are they the same? Is one bigger than the other? And to do that, both ratios need to be in simplest form. And your book just shows you a quick way to do this. 2/3, if you already know, is 2/3. You don't have to show this. Okay, but if I divide 2 by 1, I get 2. If I divide 3 by 1, I get 3. And 2/3 is 2/3. But I can make 16/24 much simpler by dividing both by 8. They both have a common factor of 8. Okay, and 16 divided by 8 is 2. 24 divided by 8 is 3, and in fact these two ratios are equivalent. They're equal to each other. So we would write yes, and this is how we justify our work, by showing that they are congruent or equivalent. Now, I'd like you to try. This is the first of 8 problems that you're going to do for this video. You only have to try these guided practice problems. So tomorrow when you walk in, I'll be looking for 8 problems. This one has 2. So I want you to tell me whether or not these two ratios are equivalent and these two ratios are equivalent. So you can pause the video and give those two a shot. And we're going to move on. So there are special names for terms in a proportion. The inside terms, when they're written horizontally like this, are called the means, and the outsides are called the extremes. Okay, and that's just how we're really going to be working with these most of the time is this example down here. All right, where I can multiply the numerator from one side and the denominator from the other, and vice versa, set them equal to each other, and if they're the same, if I get the same results, then these two fractions are equivalent. These two ratios are equivalent. All right, so let's try one. So we can use cross products to compare ratios. If their cross products are equal, then their ratios are equal. So let's find out if these two ratios, or proportion, one proportion, are equivalent. So I'm going to multiply 0.25 times 2 and 1.25 times 0.6. All right, it looks like that. I'm going to then make this multiplication. And 0.25 of 2 is 0.5, and 1.25 of 0.6 is 0.75. You can see that these numbers are not the same, so these ratios are not equal. All right, so I'd like you to try these two problems. All right, so this makes 4 total so far. So set them, make a proportion, which means set the ratios equal to each other, cross multiply, and see if those two values are the same. If they are equivalent. If they're not equivalent. Let's try example 3. So now we're going to use cross products to solve a proportion. So there's going to be a missing part of our proportion. We'll either have it as a variable term or a variable expression. We're going to use cross products and then algebra to solve for that variable. So there are really 2 types here. The first type is when we just have a variable, a missing part of one of our ratios. All right, and we're going to use cross products, okay, to find n. So I'm going to do 8 times n, and I always write the variable term first. So I'm going to write 8 times n equals 8n, and 12 times 3 equals 36. Noticing that when you cross multiply, you're getting rid of the fractions. Okay, so there's no more fractions. It doesn't matter what side you write these on. I could have written 36 equals 8n. Okay, that does not matter. You're going to get the same result. Just remember there are no fractions left. All right. I then divide both sides by 8, and I get n equals 9/2, or you could write that as 4.5. It's up to you. Let's take a look at one that's slightly more difficult. Okay, so now we have a variable expression in the numerator here. I'm still going to use cross multiplication to solve. So 4 times n plus 4, that's going to be my left side. Like I said, I always try to make the variable term my left side. Most problems were set up that way when you're taught how. Just like to keep it consistent. And then 12 times 3, I'm going to do for my right side. All right, and this is a distribution situation. So keep track of any negatives you may have out here, but in this case everything's positive. So we can distribute 4 to the n in the positive 4, and that gives me 4n plus 16 equals 36. I'm going to subtract 16 from both sides, and that gives me 4n equals 20. I'm going to divide both sides by 4, and I'm going to get n equals 5. Okay, and that would complete this problem of it. But a 5, that doesn't make sense. Oh, if I put a 5 here and 5 plus 4 is 9. There we go. I thought I had that problem messed up. 5 plus 4 is 9. 9 twelfths is the same thing as 3 fourths. All right, let's move on. I'd like you to try these two problems. So this is kind of like that first. You can always rewind and check it out. And this is like that second. Again, you can always rewind and check out that problem. All right, so solve these two problems. Let's move on to example 4. All right, so these last two are story problems, and we're going to set up a proportion. The key here for both of these problems is consistency. All right, and I'll show you what I mean by that. So the gear on a bicycle is 8 to 5. This means that for every 8 turns of the pedals, the wheel turns 5 times. So 8 pedal turns gives me 5 wheel turns. Suppose the bicycle wheel turns about 2,435 times. So we're talking about the wheel. During the trip. How many times would you have to crank the pedals during the trip? So in these problems, we're not changing gears of the bike, so this ratio will always be true, 8 to 5. And I'm going to write that as 8 over 5, and that's 8 pedal turns for every 5 wheel turns. All right, and we also know that during this trip, 2,435 times the wheel went around. All right, and I don't know how many pedal turns there were. What I want you to notice about consistency here is that the wheel turns on the left are in the denominator, and they're also in the denominator on the right side. Okay, I can't flip-flop these. What I could do, I could write 5 wheel turns over 8 pedal turns, and then put the 2,435 wheel turns in the numerator, all right, and pedal turns on the bottom, but they have to be consistent. Okay, so I'm going to be multiplying wheel turns and pedal turns, and wheel turns and pedal turns. That'll keep both sides equal. And I'm going to do that right now. So when I cross multiply, 8 times 2,435 is 19,480, and 5 times x is 5x. I divide both sides by 5, and I will get 3,896 pedal turns. Okay, labeled my answer. All right, and I am all set. I've answered that question. Okay. Example 5 is very similar. In fact, I forgot. I want you to do this part first. Okay. So it takes 7 minutes for Isabella to walk around the gym track twice. 7 minutes, 2 times around the track. At this rate, how many times, we don't know, can she walk around the track in a half hour, keeping in mind that this is 7 minutes, so you're going to want to convert this to 30 minutes. Okay? Set up your proportion and solve. You go ahead and pause this video, and we'll move on to example 5. And here's example 5. I'm going to do this one with you. You're going to do the next one. So on a model airplane, the scale is 5 centimeters for every 2 meters. So the model plane, 5 centimeters to the actual plane is 2 meters. If the model's wingspan is 28.5 centimeters, what's the actual wingspan? So I set up my proportion, 5 centimeters to 2 meters. 28 centimeters, so centimeters are across from centimeters, meters are across from meters. So again, be consistent in your setup. Centimeters across from centimeters, meters across from meters. All right, we're going to cross multiply. 5 times x is 5x. 2 times 28.5 is 57. Divide both sides by 5, and I get 11.4 meters. Okay. Now, a lot of these problems will be like model airplanes or model cars, or maps is another thing, and that's what I want you to work on next. So here's the last problem I want you to have ready for me tomorrow. In a road atlas, the scale for the map of Connecticut is 5 inches equals 41 miles. What is the distance in miles represented by 2.5 inches on the map? Okay, so set up your proportion Inches on top, miles on the bottom, equals inches on top and your x on the bottom. Cross multiply to solve, and I will see you guys tomorrow. If you like what you see, please hit subscribe. It's much easier to see these videos if you're subscribed to my YouTube channel. See you guys next time.